So in part 3 of 11, dealing with relations and functions, we're going to be analyzing quadratic functions in what we call vertex form. So when a function is written in this form, that's the form y equals a times x minus p squared plus q. That means when you graph your quadratic, this vertex, or the middle of the line of symmetry, is going to have the coordinates pq. It's going to have a domain of the entire real axis. It's going to have a range where if a is positive, y is greater than or equal to q. So that is the positive a version. And if a is negative, you're going to have y less than or equal to q, because in that case it's going to be opening down. That is the third topic. The direction of opening is going to open up if a is greater than 0, and open down if a is less than 0. The axis of symmetry is always going to be the vertical line that goes straight through our vertex. And then the x and y intercepts are going to take a little bit of more time to track down. Partly because even though they will always have a y-intercept, right, that y-intercept is it's what we get when x equals 0, so that will always be ap squared plus q. The x-intercepts may or may not exist. If you have a parabola that opens up and starts above the x-axis, there will be no x-intercepts. Similarly, if it opens down and it starts below the x-axis. If the vertex is on the x-axis, you're only going to have one intercept, and that is the coordinate of the vertex. If it's anywhere else, you will have two. So if it opens up and starts below, or if it opens down and starts above, then you will have your two intercepts. So it's finding the x-intercepts that is going to be the biggest challenge in this set. Finding the vertex in this notation is actually going to be the easiest part by far, because we can read those p and q coordinates right out of the formula. But that is the nutshell version of point 3.